everyone. Today, we're tackling something really cool, one of the most exciting fields in AI, reinforcement learning. We're going to explore how machines can literally teach themselves to master all sorts of complex tasks, completely on their own. So let's just start with the big question, right? How on earth does a machine with zero pre-programmed strategy figure out how to win a game it's never even seen before? Well, the answer is pretty incredible, and it gets right to the heart of what we're talking about today. You see, the whole idea here is a big shift in thinking. We're moving away from the old way of painstakingly telling a machine exactly what to do, every single step of the way. Instead, we're creating systems that learn for themselves, basically through trial and error, a lot like we do. So at its core, reinforcement learning, or RL for short, is all about this. You've got a software agent, and it learns by doing. It takes actions inside a specific environment, and its one and only goal is to figure out what series of actions will get it the biggest possible reward over time. And that really gets to the core motivation, summed up perfectly right here. The end goal of reinforcement learning is to maximize your reward based on a set of actions. It's that simple and it's that powerful. Everything the agent does, every decision it makes, is driven by this single-minded mission to get the best possible score. To really get a grip on how this works, it actually helps to think about it like a story. So let's meet the main characters, the key components you'll find in any reinforcement learning problem. All right, first up, we have our hero, our protagonist, the agent. This is the learner. It's the decision maker, the piece of the system that is actually taking actions and trying to figure out the rules of the game as it goes. And for our explainer today, our agent is going to be this clever fox. Now, the fox's goal is super simple. Get as much food as possible. Of course, every agent needs a world to live in, a stage to act on. In RL, we call that the environment. Think of it as the sandbox or the game board. It's the space where our agent operates and, crucially, where its actions actually have consequences. So for our fox, the environment is this field, and this field is filled with opportunities. You can see those pieces of meat, but it also has a pretty serious risk lurking around a tiger. So how does our little fox actually learn anything? Well, that's where rewards come in. This is the feedback it gets. Finding meat, that's a positive reward, a prize. Getting a little too close to that tiger? Yeah, that's a big negative reward, a penalty. And here's the really clever part. Not all rewards are created equal. The meat closer to the tiger might be a bigger prize, but the risk involved actually discounts its value. The agent has to learn how to weigh that risk versus reward trade-off all the time. And this constant weighing of risk and reward leads our agent to a fundamental dilemma. At any given moment, it has to make a huge strategic choice. Should I explore or should I exploit? Let's break that down because it's super important. On one side, you have exploitation. This means using what you already know works to get a guaranteed reward. Our fox just keeps eating the safe, nearby meat it knows it can get. But on the other side, there's exploration, venturing out into the unknown to see if there are even bigger, better rewards out there. Who knows, maybe there's a huge stake on the other side of that field. So really, the secret sauce to the whole thing is this. The most successful agents find that perfect balance. If you only ever exploit, you might miss out on the jackpot. But if you only ever explore, you never cash in on the good things you've already found. It's all about that trade-off. Okay, so how does our fox, or any agent for that matter, actually build its strategy? It's not just running around randomly, right? There's a real method to the madness, a mathematical process that guides all this learning. So the agent uses a pretty slick mathematical framework to map this all out. The official name is a Markov decision process, but don't get hung up on the name. The important thing is that it's a way for the agent to model a world like this field, a world where its decisions matter, but where there's also some randomness. It's the perfect tool for our fox to start building a winning strategy. Now, let's make this more concrete. A really popular way this works is an algorithm called Q-learning. Let's walk through it. Imagine our agent is in a maze. First, it starts in a state. Let's just call it a room. Second, it tries an action, like going through a door. Third, it gets a reward or a penalty. Positive if it's a good move, negative if it's a dead end. And here's the key part, step 4. It updates its internal strategy guide, called a Q table, with what it just learned. And then it just repeats this loop thousands, even millions of times, until that Q table becomes the perfect guide, telling it the absolute best action to take from any room to get the biggest reward. All right, a clever fox, a risky field. It's a fun story. But what's the big deal?
Why does this matter in the real world? Well, because this exact same process of learning is what allows us to build some truly intelligent systems.
I mean, the power of this kind of self-learning is just immense. We're talking about teaching machines to master incredibly complex things, like playing strategic games or controlling a robot's arm with zero explicit step-by-step instructions. It lets them make the best possible decisions in chaotic, unpredictable situations, and they can adapt and get better all on their own over time. Basically, this helps us solve problems that are just way too complicated for a human to ever sit down and program by hand. And that really leaves us with a huge, exciting question to think about. As these learning agents get better and better at exploring and mastering new environments all by themselves, what are the next great challenges they're going to learn to solve for us?